First of all, what is a coordinate plane? A coordinate plane is an important tool used to graph points and equations. It includes 4 quadrants and an x-axis and a y-axis. The first quadrant is in the top right and is called quadrant 1. The second quadrant is in the top left corner and is called quadrant 2. The third quadrant is in the bottom left and is called quadrant 3. The last quadrant, quadrant 4, is in the bottom right. Notice these quadrants go in counterclockwise order. The origin is the ordered pair located at 0, 0. This is the starting point you should look at when graphing ordered pairs. The x-axis is the horizontal line on the coordinate plane. The negative x values go to the left of the origin, and the positive x values go to the right of the origin. The y-axis is the vertical line on the coordinate plane. The positive y values are above the origin, and the negative y values are below the origin. Now we are going to graph our first ordered pair. Our ordered pair is 3, 2. In order to graph this, we need to start at the origin, which is located at 0, 0. Now that we're at the origin, the next thing we need to do is look at our x value. Our x value is positive 3. Since we know that the positive x values are to the right of the origin, we will start at the origin and move 3 spaces to the right, leaving us at point 3, 0. The next thing we need to do is look at the y value. We have a y value of positive 2. And since we know that the positive y values are above the origin, we will start at the point 3, 0 and go up 2 spaces. And that will get us to the final coordinate point 3, 2. You did good on the first one, so let's try another one. Our next ordered pair is negative 4, negative 5. The first step is starting at the origin. The next step is looking at the x value. We have an x value of negative 4, and since we know the negative x values are to the left of the origin, we will start at the origin and move 4 spaces to the left, leaving us at the coordinate point negative 4, 0. The next thing we will do is look at our y value. We have a y value of negative 5, and we know that the negative y values are below the origin. So starting at the coordinate point negative 4, 0, we will go 5 spaces down. This will give us our final coordinate point of negative 4, negative 5. So, I bet you're dying to know, what is a linear equation? Linear equations are used to graph lines on the coordinate plane. The formula for linear equations is y equals mx plus b, where m is the slope and b is the y-intercept. The slope, or m, determines how steep the line will be. The slope can either be positive, or the slope can also be negative. The y-intercept, or b, determines where the starting point of the line will be on the y-axis. There are 4 steps you can use to graph linear equations. The first step is to make sure the equation is simplified and is in the slope-intercept form. The second is to graph the y-intercept. The third is to use the slope of the equation to graph other points. And the fourth and final step is to connect the points to make a line. So let's take a look at this linear equation here and go through the steps. The first step is it simplified? Yes, it is, so we can move on to the second step. The next step is graphing the y-intercept. The y-intercept in our equation is a positive 4. So from the origin, we will go up 4 spaces to land at the point 0, 4. And that is how we graph our y-intercept. So after graphing our y-intercept, the next thing we want to do is use the slope of the equation to graph other points. So in the original equation, the slope is 3. This is the same as 3 over 1, and writing it as 3 over 1 puts it in the rise over run form, which makes it easier to graph. So starting at the point 0, 4, where we graphed our y-intercept, we want to use the slope 3 over 1 to go up 3 spaces and to the right 1. Since there's no more room at the top of the graph and we want to include one more point, we will have to take the negative form of the slope, which would be negative 3 over negative 1. And starting at the y-intercept point of 0, 4, we will be going down 3 spaces and to the left 1. Notice that this does not change the original slope of 3 because negative 3 over negative 1 is still 3. By changing the slope values to negative, it makes it easier to plot points lower than the y-intercept ordered pair. And for the last step, after you have plotted a few points, connect the dots to make the line. I would like to try one more example. So going off the steps we learned before, the first thing is to make sure the equation is simplified. This equation is not simplified, so in order to do that, we want to divide the whole equation by 2. So let's do that first before we do anything else. So 2y divided by 2 equals y. Negative 8x divided by 2 equals negative 4x. And 6 divided by 2 is 3, giving us our new equation, y equals negative 4x plus 3, which is simplified. The next step is to graph the y-intercept. The y-intercept in our equation is a positive 3. So from the origin, we want to go up 3 spaces so we finish at the point 0, 3. The third step is to use the slope to plot more points. Our slope in our equation is negative 4, which is the same as negative 4 over 1 in rise over run form. The next thing we want to do is go from the plot intercept point, which is 0, 3, and go down 4 and over 1. We will repeat the step again, except this time we will go from the new point instead of the slope intercept point. And now that we have 3 points, we will connect all the points to create the line.